Welcome to part one of our reproductive systems lecture. And I want you to notice that it's called reproductive systems and not reproductive system because it's essentially two separate systems. Male and female systems are going to work very differently. This first lecture is going to be really short, and it really only matches to the very first page, page 545 of chapter 16. It's just going to introduce some ideas I want you to start thinking about. This is a very unique system, or two systems, compared to all the other systems we've talked about this year for several reasons. First of all, unlike most of our other systems, it does not function continuously. A lot of these systems don't even start to activate until puberty, and then they're going to vary depending on how active they are, depending on what's going on in regards to reproduction. It's regulated mainly by hormones, and we've seen a lot of systems that do have some hormones regulating them, but this is almost entirely regulated by hormones instead of by the nervous system. And you'll remember from our endocrine system, hormones were different from nervous system control because they regulated things that happened in cycles, that were ongoing processes, that were very slow, which is applying to production of a new person. The other thing that makes them unique is most of the systems we've seen had some little variations depending on whether it was a male or female, but for the most part they were the same system. That's totally out the window for this one. The male system and the female system have very little in common. And lastly, all of the other systems we've talked about this year were designed to support the person they belong to support that life, to keep homeostasis in one person. This system is not designed for the person that it belongs to. It's designed to create a new life. So that idea of maintaining homeostasis for the current life is no longer applicable. All right, we're just going to talk briefly about the main functions, and because it differs so much between male and female, then we're going to wait to go into detail until we're talking specifically about one or the other. So the main function, regardless of whether it's the male or female system, is to produce offspring. Okay, everything the system is designed to do is to make sure that a new life can be brought into the world. So for males, this means their part of producing offspring is to produce and then to deliver sperm. For females, they need to produce ova, which is just the scientific name for eggs, and then they need to provide support for an embryo to develop. Regardless of whether it's male or female, we call the primary sex organs gonads. So in males, these are the testes. In females, these are the ovaries. Either way, their functions are to produce gametes, and we'll talk about what gametes are in a moment, and to secrete the sex hormones. So in males, testes produce the sperm, which are the male gametes, and secrete sex hormones, in that case mainly testosterone. In females, the ovaries produce ovum or eggs and secrete estrogen, which is the main female sex hormone. And then there's going to be various accessory reproductive organs. So the gonads are doing the primary work, and then the accessory reproductive organs are going to help carry out future tasks. All right, one thing I want to talk about quickly before we get into the specifics of the male and the female reproductive system is something that hopefully you saw in biology. So if you need to review this, you might want to Google a YouTube video or go Google fertilization in zygotes and make sure you remember what meiosis is all about. So I like this diagram because it kind of simplifies it. So here we have obviously a male and a female. And if you remember, all of our cells have a certain number of chromosomes. And that's what this N refers to. N is the number of chromosomes we get from our mom, also the number of chromosomes we get from our dad, which is why there's a 2 in front of that. Okay? So we get 23 from our mom and 23 from our dad. We should have 46 chromosomes, and those pair up. And so in every cell in our body is going to be diploid, and that refers to having 2N. We have 23 from our mom, 23 from our dad, for 46 total. So all of our cells are diploid. They have a complete set of information. What our gonads are going to do, so in the case of the male, the testes, or in the case of the female, the ovaries, is a process called meiosis. And this is cell division. We're going to make new cells. But in the process of dividing, we're going to cut this diploid number in half. Dad only gets to pass on 23 of his 46, and mom only gets to pass on 23 of her 46. That way, when dad's 23 from the sperm and mom's 23 from the egg come together, we're back to 46. If we didn't cut it in half first, we'd be multiplying, 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 out of control. We'd have so many chromosomes they wouldn't even fit in a cell. This is also the reason that you're only partially like your dad and partially like your mom. You didn't get all of their DNA, you only got half from each. Okay, so here's the idea. Meiosis happens to create from one regular diploid cell with a complete 46, it creates the gametes, either sperm in the case of males or egg in the case of females, that are haploid. You see down here, haploid, meaning they only have one set of ends, so they're only going to have 23 chromosomes. And I realize in this drawing it's using 3 and 6 because it's simpler, easier to fit on the drawing. Once the sperm fertilizes the egg, that haploid and haploid come together, 23 and 23 come together, and we are back to 46. So we're back into diploid world. That new cell, that very first cell that's the sperm and the egg combined, has your very, very first set of DNA before it multiplies to make you, is called a zygote. This cell is going to do something called mitosis. Also cell division, we're also making more cells, but this time we're not going to half the number. We're just going to literally copy the cell. So we're going to make more of it, more of it, more of it, more of it, more of it. You're going to grow into an embryo, a baby, eventually back to a male or female, depending on whether you have an X or Y chromosome. So I'm going to tell you a really cheesy kind of joke now that I use for my biology class to keep mitosis and meiosis separate because they sound very similar. They both start with M and they're both about cell division. And what I tell my biology students is mitosis is just about cell division, just about making more cells to grow, to heal a cut, no big deal, not very sexy. And meiosis is about making these sex cells, the gametes, that are going to go on to create a new person in the process of reproduction. So meiosis essentially has to do with sex. So what I tell them is that if I walk down the hallway and I hear them talking about mitosis, talking about healing a cut, I'm really not going to give it much notice. But if I walk down the hallway and I hear you guys talking about meiosis or talking about sex, I might go, oh my. So I tell them to remember, oh, meiosis has to do with sex, whereas mitosis has to do with growing and healing. All right, that pretty much sums up what I wanted you to look at for part 1. Again, it's just a quick introduction. Part 2 is going to start talking about the specifics of the male reproductive system.